Did you get my message about the test?
I didn't see it.
Okay, so I'm gonna give you a chance to finish just for this test. So can you come in either after school today or before school Monday?
Probably do it before school Monday.
Okay.
Because I got weights after school.
So do you want to come at 7:30 on Monday? Okay, and you'd only be able to finish the ones that have blank, you know, but you can do that just for this test, okay? All right, guys, we're gonna get started.
All right. Yes, ma'am.
Is the assignment a worksheet or in the book?
No.
If you have an assignment the day after a test,
Somebody throw my desk.
Today's not bad if you're good at algebra.
What do you mean?
It's solving equations.
Oh, kind of equation.
I was like, right when you were walking out, I was like, yo.
With solving
Why are you doing that?
This is like,
you don't stand on both.
Okay.
Are the notes only one page?
They are.
Let's go.
Okay.
why do you do this?
Yeah.
All right. So.
Well, Nancy got you in mind.
Okay. So I just want to talk a little bit about the tests. When I give a test, I do expect it to be done in class, and I didn't say that officially yesterday that I'm aware of. But when I give a test, I guess I assumed most of you had me before, and so you always are to finish the test in class. And then the second thing is, I don't know how things have, like how things were, but I don't answer questions on tests. So I expect, on tests it's what you know, not what I know. So just so you're aware of that, just in case that's different than what you've had, first trimester, but I expect it to be what you know. And then the other thing is,
I don't know.
make sure that when I give you the practice test, you know exactly what the test is going to be like. It's like same amount of questions, same exact format. So when I give you that, if you don't know how to do everything on the practice test, what I would do if I were you is I'd keep that practice test when you're done, and I would look through it several times to make sure you know how to do everything that's on there, okay? For you, there should be no surprises. So when I grade a practice test and there's sections that kids skip, to me that says you didn't know what you were doing, okay? So I just wanted to point that out today before we get started. So you're gonna need a calculator today.
Oh.
You don't know? Any sharpening your pencil for me?
I can do it now.
No, I want to do it. I want to do it.
Go ahead.
I'll
There you
get
go.
you the notes then. I probably marked you absent, so remind me to switch that after.
You didn't mark me absent.
Did everybody get
Absent.
get a calculator that needs one? Okay. All right, so
No, I said that wrong.
we are going to today solve equations. And like I said, honestly, it's a lot of algebra to solve, and you're dealing with decimals and stuff a lot of times, but it's not, the log part of it that's new is just like one step, and then you're basically just doing algebra to solve an equation. So we are talking about common logarithms today. And a common logarithm, if they ever say find the log of 10, and they don't, and that's a bad example. I should have said like log of 5, let's say. Okay, and they have nothing right here. What you are to assume is that it's log base 10. And on your calculators, you guys have a log key that is to the left of your 7 key. That key is log base 10. So if I asked you on the test, which actually you'll have problems like this today, not many, but so this one says log base 5. All you have to do is hit that log key to the left of the 7 and hit 5. And then they usually want you to round it to the 10,000 place, which is 4 decimal places. Okay? So, did you guys get 0.6990? Okay? Then try log 0.3. You can get negatives.
I got an ad.
What did you get?
An ad.
This is on like.
Oh, did you guys get like negative 5.5229?
Yeah.
Okay, this is important, okay? When you take the log, you can get a negative answer, but you can't, like try to take log of -2.
Don't worry.
And it probably says error, right? So that is, when you take the log, you can't take the log of a negative, but you can get a negative answer. Do you see the difference? Okay. All right, so sometimes today, we are again going to have to switch from the logarithmic form to exponential form using that log loop. And then there's times that we have to do it the other way, okay? If you see something like this and they're asking you to put it in exponential form and there's no number down here, it's log base 10. So when you do that log loop, do you get that it would be 10 to the y power equals x? Everybody understand that? 10 to the power of y equals x. That's just using that loop. Same thing here, there'd be like a 10 here, so it'd be 10 to the 0 power equals 1. And is that true? Is 10 to the 0 power equal to 1?
Yeah.
Yes.
Yeah.
And then here is just 10 to the first equals 10, and that's true. And then this one would be 10 to the power m equals 10 to the mth power. Okay, so that's just showing going from the log to the exponential form. So we earlier in this chapter had a section where we would get like 2 to the x equals 8. And I'd say solve for x. And that's kind of an easy one. But do you guys remember when we did this, we tried to get both things to the same base? And then we got rid of our bases and we said x is 3. Everybody understand that? Now, what we're going to do today is we're going to do problems where you can't write these two numbers to the same base. And what you have to do then is you are going to use the fact that you're going to simplify both sides as much as you can, and then you're going to take the log of both sides, okay? So the first thing that you're going to do here is you're going to say log of 4 to the x power equals log of 19. So when you can't write those two numbers, 4 and 19, to the same base, that what you can do to undo an exponent is take the log. So do you guys remember from the rules of logs, can't I take that x out front, right? And now if I'm solving for x, all I have to do is divide by log of 4 on both sides. And this is something I can punch into my calculator. When you do this, however, either put a parenthesis after 19 or hit your enter key. Okay, so you're going to want to go log of 19, enter or parenthesis divided by log of 4. So log of, what was it, 19? Parentheses divided by log of 4. Did you guys get 2.12? And it does say to the nearest 10,000th again. So that's 4 places. So if this is 39.6, what would you round that 39 to? 40. So do you get it would be 2.1240? Everybody understand?
1.24.
1.24, you can do that too. Adding that 0 is, I mean, you can, but you don't have to. Okay? So x is going to be 2.124, and you could leave it like that or add a 0. Okay? So again, with that 6 and that 8, we can't put 6 and 8 to the same base. So then what I would do is just go log of 6 to the x plus 2 equals log of 18. What could I do with that x plus 2? Bring it out to the front, okay? So then I'd have x plus 2 times log of 6 equals log of 18. Now, there's really 2 different ways you could do this. You could find log of 6 as a decimal, find this as a decimal, and then distribute this decimal across the x plus 2. Or another way you could do it, and actually that's probably how I would do it, but you also could divide both sides by log of 6 and evaluate this as a decimal. Actually, let's do that. Let's divide by log of 6 on both sides. So I would get x plus 2 equals, and we're going to do log of 18 parentheses divided by log of 6. Did you guys get 1.6131? Okay. So, yeah, I think this is actually the easiest way. 1.6131. And then what would our last step be? Just subtracting 2. So we would get x equals, what would that be? Negative point. Thank you. All right. So if we look at C.
Yo, is that squared?
Yes, x squared. 42 to the x squared. So what we could do is still take log of both sides. Okay, and then bring the x squared out front. Now, again, depending on how you want to do, we could get rid of this log of 42, divide by log of 42 on both sides. And you'd get x squared equals, okay, let's do log of 84 divided by log of 42. Did you guys get 1.1854? And then what would I do? Square root. And x would equal, yep. All right. These right here are kind of a pain, to be honest, when you have 2 bases to something like n plus 1 and n 2n minus 1. It's just going to end up being kind of yucky algebra. So we have log base 2 of n plus 1 equals log base 5 to the 2n minus 1. What would you guys do first? Put the n plus 1 in front, yep. And we'd have log base, a log of 2, okay? And then we put the 2n minus 1 here, okay, of log base 5, okay? Now, honestly, in this one, what I would do is I would evaluate log base 2 on my calculator and put that to 4 decimal places. And I would do log of 5 on my calculator, put it to 4 decimal places. And for some reason, I only have mine to 3 decimal places. So let's see. If you do log 2, oh, so it is 0.301. And then when you do log 5, do you guys get that? This would be 0.6990. Do you understand that? So that's why I have each of them to. So I'm going to do this. I have n plus 1. Log base 2 is 0.301. This is 2n minus 1. And log base 5 is 0.699. Now, it's not that this is hard. It's just kind of yucky numbers to work with. But would you guys know that you have to distribute this? Say that again. Did you divide by like 0.301? Because you could bring that decimal over here and divide it.
Divided by log 2.
You divided both sides by log 2, and then you got a decimal over here. That would work.
It's just,
Is that what you did?
yeah, but I'm not distributing anything, so.
Oh, you are going to end up having to distribute. So we are going to have to distribute on both sides. So we get 0.301n. 1 times 0.301 is 0.301. 2 times 0.699 is 1.398, and we have an n. And then 0.699 times a negative 1 is minus 0.699. And then you're just, like I said, using algebra. So I'm going to bring this 0.301n over to the right. And I get 0.301 equals 1.097n minus 0.699. And then I'm going to add 0.699 to both sides. And we get 1.097n equals 1. And then what would our last step be? Divide by 1.097. So when we do that, 1 divided by 1.097 is 0.9116. Everybody okay with that? So yeah, just yucky numbers to work with, but it's not necessarily that it's super hard. Okay? This is exactly the same, except we have, instead of an equal sign, we have a less than or equal to, or greater than or equal to, or less than or greater than. So again, same thing. We take log 3 to the 5y is less than log 7 to the y minus 2. Okay? And then we're going to bring our powers out to the front on both. So we get 5y log of 3 is less than y minus 2 times log of 7. Okay. So again, probably what I would do is just evaluate both of these and put them as decimals to four places. And log of 3 to 4 places is 0.4771. And then here, log of 7 is 0.8451. Over here, then, you would just multiply the 5 times 0.4771, and that would give you 2.38. And I would always try to keep my numbers to 4 places. So that ends up being 2.3855 times y is less than, and then I have to distribute this. So when I go 0.8451 times y, I get 0.8451y minus 0.8451 times a negative 2 is minus 1.6902. Now, one thing I noticed on the quiz, and this is absolutely fine, typically when I teach solving inequalities, I bring my y's to the left regardless what happens. And I noticed a lot of you left them on the right, and that's okay. This particular one, however, you only have this one number, so you're going to bring your y over, okay, and leave this one number over here. So we're going to subtract 0.8451 y from both sides. And 2.3855 minus 0.8451 is 1.5404y is less than negative 1.6902. Divide by 1.5404 on both sides. And when we do that, we would get, we don't have to switch our sign. We're not dividing by a negative. I got negative 1.0972. If you are off just slightly, it could be just how you round it, but if they're asking you to keep it to the 10,000th, I would just keep all my decimals throughout the problem to 4 places. Does that make sense? So this is the answer. Now, B is similar. Do you guys want to see another one like that, or do you get it? You get it? Okay, let's go down to C. Okay, again, we're going to do log of 16 to the y is less than or equal to log of 1/4. Okay, then you're just going to bring your y out front. So we have y times log of 16 is less than or equal to log. And if you don't like dealing with fractions, you certainly could think of that 1/4 to the 0.25. That's absolutely fine. And honestly, what I would do then on this one, you only have a y over here, so I divide by log 16. And we would get y is less than or equal to, did you guys get like negative 0.5 or somewhere around that?
Yeah,
Did you get exactly that?
yeah.
Negative 0.5? Okay. So like I said, I don't think this is super hard. It's just a lot of decimals to deal with. Do you guys agree? Or do you think it's not too bad? Okay. Now let's go to the last page. This is actually something that I did teach, but they bring it back again. And actually a few people did not know how to do this on the quiz. So we're going to go over this again. Change a base formula. When you do this, and this is in your cheat sheet, you would take log of whatever this number is on top divided by log of the base on the bottom. Okay? So this is the same. The only difference is, in this case, like we would bring the 5 out front. So we'd have 5 times, you don't really have to rewrite this, but I will, log base 8 of 4, okay? And then to do the change of base formula, it would be 5 times log of what? 4 or 8? 4 divided by log of 8, okay? So you can type that in just as 5 log 4 parenthesis divided by log 8. So 5 log 4, parenthesis, divided by log 8. Did you get like 3.33333? Okay. So that would be your answer. So we're going to keep things to 4 decimal places today. Now this one, we want to write the square root of 5 as a power so that we can bring that power out front. What power is the square root? 1/2, correct. All right, so what I can do then is bring that 1/2 out front. So it'd be half log, you don't have to write this step, but it would be log base 7 of 5. Again, if you don't like dealing with that half, you certainly could write that as 0.5. And now we would do the change of base formula. So it'd be log of 5 divided by log of 7. So 0.5 log of 5, parenthesis, divided by log of 7. Oops, I did a negative instead of 0.5 log of 5, parenthesis, divided by log of 7. Did you guys get 0.4135? Okay. All right, last one here. We have log base 4 of 39 to what power? If it's a cubed root, it's 1/3. Now this one, you can't change that to a decimal very easily. If you just do 0.33, you're going to be off a little bit. So let's just leave this one as 1/3 log. And then do you get on the top, it would be log of 39 divided by log of 4. So when you enter 1/3 into your calculator, just so you can get a more exact number, to enter a fraction, if you don't know how, you're going to do parenthesis 1 divided by 3 parenthesis. That's how we're going to enter every fraction we ever have. And then it would be log 39 parenthesis divided by log of 4. And did you guys get 0.8809? No one?
Isn't there another way you can do the fraction?
Yeah, there is. There's some,
I don't know.
there is, but
Thought there was.
I never use it. It's something, does somebody else know?
Second negative?
Second this? Is that what you mean?
Yeah.
No, that's.
No,
Oh,
that's how to get the answer.
math one.
Math?
You change your answer into a fraction. Oh, well, yeah, but like, how do you answer it?
Like if you were,
Yeah, I know, I remember.
there is a
we had-
way,
I
because
just-
somebody just told me about it.
Second var, binomial PDF, no, I'm just kidding.
Anyway, there is another way. Okay, so this is your assignment, okay?
We could have looked at that on this thing. Forgot to bring it down when we printed it.
I guess so, yeah.
You should always do that.
Yeah.
You can do
You should do that because I don't have to actually be
that. You know, during distance learning in ninth grade, I would watch about 10 minutes of your video, not even,
And
and do your homework.
always keep those up so we don't always have to write it down.
No, I don't think it'd kill you to write it down.
Oh,